Welcoming to the stage Dr. Assaud.
Okay, so good morning everyone. So first of all, I would like to thank the organizing committee and also acknowledge this good initiative to organize this day. I think it's very important and it's a very good initiative. So yeah, today, I will try to introduce you some processes and technologies related to energy production, conversion and storage. So as Philippe introduced us, energy is a key point for the next coming years. So first of all, if you look at the context, and if you look at the energy mix of today, of course, as you can see here from this diagram, we are still using mainly resources coming from fossil fuels. And resources is a key point in this context. If you look at the resources of oil, there is still for about 40 years, gas for 60 years, and coal for 200 years. So of course we need to change this paradigm and change our use of energies going to renewable energies. If you look at this diagram here, oops, it's working. So of course we need to increase this very little part here corresponding to renewable energies. In the same time, if you look at the CO2 content into our atmosphere, we can see that there is a huge increase of CO2 in the atmosphere from the middle of the 19th century. And of course, this will lead to increase of temperature, climate change, and all the problems that occurs on our planet nowadays. So we really need to find new way to produce cleaner energies. So if you look at the energy mix, actually we can see that we are a lot of possibilities, a lot of energy, primary energies available. So fossil fuels, of course, but also many other resources, sun, wind, and many others. But the fact is that when you are using renewable energies, that we see that we are facing another problem, which is the intermittence of those energies. Because of course, if you think about using light coming from the sun is shining during the day, but it's not shining during the night. So of course, you cannot produce energy continuously. It's same for wind. If you think about using wind, of course, we don't have wind anytime. So now there is this other question, how we can solve this problem of intermittence, and of course we need to store this energy. So we need both to develop new technologies to produce cleaner energy, but also new technologies to store and convert this energy to make it usable for different applications. And if you want to use this energy into applications, actually we need to use energy vector. So what is an energy vector? If you look at the full chain of energy, you start from this side of the chain, which is the energy mix. So this consists of fossil resources, nuclear, renewable energies. At the other extremity of the chain, you have the utilization of this energy for different applications in industry, transportation, grid. And to link the two extremities of the chain, you will need to use an energy vector. So what is an energy vector? It will consist of something that will allow you to convert energy. And it can be electricity, hydrogen, heat. And all these energy vectors will need to be converted, distributed, stored to be usable in the final application. So, of course, I will not have time to describe all the primary energies that are available in the renewable energy mix today. But I would like to mention some of them. So as you can see, there is many different sources of energy that we can use. You can use energy coming from wind, coming from sun, coming from geothermal, coming from hydropower, tidal energy, biomass. So we have a lot of possibilities using all these different primary energies. And I think that we don't have to focus only on one primary energies, but we really have to develop all of them together in parallel, because I don't think that if we focus only on one energy, it will be enough to meet the need of energy in the next coming years. So we really need to develop technologies on all these systems. So I will not have time to describe all the systems, but I would like to focus more on solar energy possibilities. And with this kind of energy, you probably heard about photovoltaics. And for photovoltaics, there is a need to improve or design new materials, being able to absorb light from the sun, so photons. And the aim of this material, which is called semiconductor, is to absorb photons to be able to create or to generate electrons and to collect these electrons to generate electrical current, to generate electricity. And semiconductors, you have different kinds of semiconductors and different kinds of systems that will allow you to produce electricity using the light coming from the sun. And I tried to summarize here the different technologies available today. So some of them are available on the market, and some of them are still in the labs and require improvements. So you probably know the silicon technology, which is the most known and the most sprayed into the industry nowadays. So you have polycrystalline silicon, you have thin film silicon, then other technologies, thin film technologies, organic photovoltaics, or even Dyson-sensitized solar cells. And also what you have to think here is, of course, the use of resources, as I mentioned before. So it's the case for fuel resources, but it's also the case for resources of materials that you are using in all these systems. So, as I mentioned before, you need to find appropriate materials to be able to convert solar energy into electricity. And of course, you have to think about the availability of resources of these materials you want to use in these systems. And what you have to think about also is the whole life cycle of your system. So it means that when you are using a photovoltaic cell, of course it's virtuous, you are only using light coming from sun, you are creating electricity. But you also have to think about what amount of energy you needed to prepare and to create your solar cell. And if you take, for example, silicon, then you will think that the process you need to implement to be able to generate a solar cell, it's very costly in terms of energy, because the process needs a high energy, high heat. You have to heat up silicon oxide to be able to create polycrystalline silicon. So it's very costly in terms of energy. And then you are using your solar panel, so let's say during 20, 30 years, and at the end of the life of your solar panel, again you need to recycle your solar panel. And once again it's costly in terms of energy. So now you really have to think about the whole life of your material you are using, from processing, using and recycling of your system. It's very important. Of course, you also have to think about the availability of resources. For example, sun. If you take the example of France, and if you look where we have sun, of course, your solar panel will be more efficient if you put it in the south than if you put it in the north. So it's also a problem that we are facing, because not all the technologies are appropriated for all the places in a country, for example. So this is also a problem we have to face. Another technology I wanted to mention using sun is nuclear power. So we are hearing about nuclear power. There is a lot of problems with nuclear power. Nowadays we are using a fission process. And in the future, we are now thinking about using fusion process. So instead of using fission, so it means that you start from a big nucleus and you split it into a smaller nuclei to generate energy. Using fusion, it's the opposite. You start from little nuclei, you will make the fusion of them, and you will create a bigger nucleus and even a higher energy than the one which is generated by fission. And with this kind of technology, we think that we will be able to generate a very huge amount of energy, being able to meet the demand of our planet. But once again, there is a problem of materials. These reactions are actually the reactions that are taking place at the surface of Sun. And as you can imagine, the temperature at the surface of Sun is very high. It's about 150 million degrees Celsius. So of course you need to find materials that are able to resist to this high temperature. So once again, there is this question of materials. So as you can see here, material is a very key parameter for the next coming years, and we really have to figure out new materials or to design new materials or to combine new materials together, being able to have new properties for these materials. So now, as I mentioned before, we saw that there are many renewable energies available, but as I mentioned, they are intermittent. So now the question is how to store, convert these renewable energies. So the conversion of energy is also a key point for the next coming years. And actually there are different technologies that can allow to store or to convert energy. And so I will not have time to discuss all the technologies, but I would like to focus on two of them. The first one is hydrogen and energy. And we are usually talking about power to gas. So what does it mean? It means that when you are producing electricity, for example, using renewable energies, so wind, water, or solar cells, so when you are able to generate electricity, so when the sun is shining typically, and you have an excess of energy, then the idea is to convert this energy, this electricity, into another form of energy, and for example, chemical energy. So you will convert electrical energy into chemical energy. And for that purpose, you can use electrolysis of water. And in that case, the idea is to split water molecules into oxygen and hydrogen. And basically, you will store your electrical energy into chemical energy. So it means that you will store energy into chemical bonds contained into a hydrogen molecule. And then this hydrogen molecule, you can store it, you can distribute it, and you can finally use it in a thermal motor or in a fuel cell, again to generate electricity. So it means that when you are producing excess of electricity using all these different technologies, you will convert it into another form of energy, chemical energy, and again, when the primary energies are not available, you can convert your chemical energy into electricity. And it's like a cycle, and of course what we want to do is a virtuous cycle using only abundant resources. And this is the virtuous cycle of hydrogen. So you can imagine starting from electrolysis, and instead of bringing electricity to your system, to the electrolyzer, to be able to split water molecules into hydrogen and oxygen, you can think about not bringing electricity, I mean energy from electricity, but you can bring energy from sun. And in that case, you will use only water and sun to generate hydrogen. No more need of electricity. Then you need to store hydrogen. So there are also, I will not focus on that point today, but there are many different technologies that allow you to store hydrogen. And then you can use hydrogen in a fuel cell to generate electricity. And the only things which is coming out from a fuel cell is energy and water. And in that virtuous cycle, you see that you only use water, sun, and you can generate different forms of energies. So this is very virtuous. Just to mention some thermodynamics consideration, if you look here at the energy which is related to the reaction which is taking place in a fuel cell, so it's exactly the opposite reaction that is taking place in an electrolyzer. You will combine hydrogen and oxygen and you will generate energy and water. And if you compare the energy generated by this reaction with the energy generated by the same amount of common fuels, such as oil, you will see that the energy is 3 times higher for hydrogen. So this is very interesting. Here is a comparison of hydrogen and all the different common fuels, and you can see there is 3 times more energy. Of course, there are other parameters, and the idea is to increase the energy density of the hydrogen, because of course it's a small molecule, so it's not easy to store it, so there are some issues, and research is here to improve these systems, to make more efficient systems. So, as you can see, hydrogen can be interesting to convert and to store energy. But today, if we look at the processes to produce hydrogen, you can see that hydrogen is mainly produced from fossil fuels, from fossil resources. So mainly from methane, hydrocarbons, and not from water. So this also has to change in the next coming year. We have to develop new systems being able to generate hydrogen from renewable energy, resources and not fossil resources. So the most common technologies that are used today to produce hydrogen are from fossil sources, so evapocracking of methane, partial oxidation processes, from biomass, and a little bit from water, but it's not the main technology which is used today. So there are need of improvement of this technology. So why we don't use too much electrolysis? And once again, it's because of materials, and we have to develop more efficient materials. Because one of the limitations in this system, so it's a schematic of an electrolyzer. One of the major issue is the material we need to use to make this reaction possible. Because if you look at this reaction, so you want to split water into hydrogen and oxygen, so it seems that it's an easy reaction, but it's not. It needs a lot of energy to be able to split water into oxygen and hydrogen. And for that purpose, you need to use special materials that are catalysts, and these catalysts are mainly noble metals that you are using, so they are expensive, they are not too much abundant. So once again, we have to design or to find new materials, more abundant, cheaper, to be able to improve this technology. So finally, because I think I have only 2 minutes left, I would like to mention another system to convert energy, which are based on electrochemical storage. So it's mainly batteries, and in batteries you can convert, once again, chemical energy into electrical energy. So there are different kind of technologies of batteries for different applications. And just here, if we compare the different technologies, so you have lead batteries that were mainly used a few years ago. And if you compare lead technologies with other technologies, for example, nickel cadmium, nickel metal hydrate, or lithium-ion batteries, you can see here the improvement of the technology. To run the same distance, you needed a battery with a weight of about 15 kilograms, and for the same distance, if you replace this technology by lithium-ion batteries, you can decrease by a factor, let's say 4, the weight of your battery. So of course it will be more efficient, so we can develop more efficient technologies and systems to be able to store energy. So here is a comparison of the different technologies, electrochemical technologies to store energy. And once again, electrochemical energy storage systems are very versatile because you can use different systems depending on your application. If you want more autonomy, so it means, let's say, a small amount of energy but during a long time, or in the opposite, if you need a high amount of energy during a small period of time, you can select the most appropriated system that you can use. So I will have no time to go into the details for the lithium-ion technology, but it is the most promising one at the moment. You maybe heard about the Nobel Prize of Chemistry in 2019 that was awarded to these three professors for lithium-ion technology. So it's a very promising technology for the next coming years. Once again, to mention the resources, of course, if you take the periodic table, you need to select the appropriated material or element you want to put into your system. And if you consider the toxicity, the price, the abundance, the weight of material, finally you see that there is a few elements appropriated for these technologies. And here are the most appropriated elements. So you see that there is not a lot of choice. But even if there is not a huge choice in terms of elements, you can combine them together. You can play on the morphology, on the crystallinity, on all the physical chemical properties of these materials. And you see that they are very versatile, and you can reach very good performances with a few number of elements just by combination and playing with the morphology, shape, crystallinity of these materials. So it's very versatile. And finally, just an example for automotive application. If you look at a car, you see that basically in battery electrodes there is more than 50% of the mass and volume of these electrodes that have non-electroactive parts. So we need on one side to improve the material, but on the other side we need to better understand the limitations taking place in these systems, and by better understanding these limitations we can improve also these systems. So finally, if you compare hydrogen and batteries, most of the time it's like an opposition of these two technologies, but actually it's not an opposition, they are very complementary technologies. And once again, it's not only one technology that can meet the need of energy, but you have really to work in parallel on all the different systems available. So here is my conclusion. So as I mentioned, the key point, of course, resources. You have to think about resources. It's very important for the next coming years. And there are a lot of technologies, and you can really play with these materials to be able to generate efficient systems for future. Finally, I would like to thank all the students that I have the chance to work with. And also it's a message for you, because we are counting on you to develop these systems, to go into industry or into academic lab. And we need the help of everyone, and everyone can play a huge role into the energy transition for tomorrow. So finally I would like to thank you all for your attention.
So we have time for questions from the audience.